Here are solutions to homework set number 1 for ECE 111 for fall 2024. Now the first problem is asking you to go to Bison Academy. On Bison Academy there are homework sets and solutions. If you go to Bison Academy ECE 111 homework sets and solutions, you've got solutions for the various semesters in the past. So for example, if you want to find out how do you do some homework problems, you can go back to spring 23. Here's the various homework problems that were assigned and solutions. This one was how to find the solutions to two equations to unknowns, something we'll cover a little bit later. If you graph them, I can see the solutions in MATLAB, which turned out to be two solutions. X is minus 1.8, y is 0.22, x is 1.1, y is 0.38. So if you ever get stuck on the homework sets and you need a place to go to, maybe to get an idea how to do the homework, try to figure out what MATLAB commands you need to use, the old homework sets and solutions are a good place to go. The numbers change every semester, so just don't turn in a copy of the previous homeworks. It is different every semester, but kind of the same idea. We'll get you an idea how to get there. Problem 2. With MATLAB, I can find the roots to polynomials. The trick to do that is, MATLAB is a matrix language. I have to input the coefficients of the matrix, or the polynomial, as a matrix. So this is 1x cubed minus 13x squared, 35x, 49. To find the roots of that polynomial, I got 3 roots, it's a cubic. Try a fourth order polynomial. Again, it's in decreasing powers of x, the way you input it into MATLAB. Fourth order polynomial has 4 roots. And a fifth order polynomial has 5 roots. Now they could be real, could be complex. MATLAB handles real numbers and complex numbers with ease. What the numbers mean, if you plot them, the real numbers are where the function crosses the x-axis, and the complex roots are where it misses the x-axis. MATLAB can be used as a graphing calculator. For example, if I have a thermistor where the resistance varies with temperature and a voltage divider where voltage varies with resistance, I can plot and do calculations. So for example, if you just want to know a single point, like at minus 20 and plus 20 degrees Celsius, I just plug it in. When t is minus 20, I type this equation into MATLAB, and here's the syntax. exp is e to the x. I need to use parentheses. So 4200 divided by t, without the parentheses, is going to do left to right, divide by t first, then add 273. With parentheses, it does the addition first. Well, you should get 24 kiloohms. Plug in the voltage divider, 8.59 volts. So basically, MATLAB is a calculator. At 20 degrees Celsius, same procedure. At 20 C, I have 2.5 kiloohms, 3.88 volts. So it's just a calculator. I can plot. So for example, here if I go from minus 20 to plus 20 degrees Celsius, steps of 0.01, this is going to give me 4,000 points in t. I don't have to do all 4,000 points separately. I can do them all at once. I just use the same equation we had before. The trick, though, is this is technically a matrix. If I do a slash, it's trying to do matrix divide. I don't want to do that. This is just 4,000 numbers. Do each calculation separately. And that's what the dot slash means. It means go element by element. For each temperature, calculate the resistance, plot temperature versus resistance, label the axis, and that's what she looks like. Now what a graph does for you is I can sit there and say if I'm at 5,000 ohms, so this is times 10,000, there's 10K, 5K, at 5,000 ohms, there's the temperature. If I'm at 10,000 ohms, I come over here, there's the temperature. So a graph is a nice way that if I know one variable, I can read off the graph what the other variable is. Given resistance, I know what temperature is. I can also plot voltage. So once I know temperature, I know resistance. Once I know resistance, I know voltage. And again, I need to use that dot slash notation. Again, telling MATLAB, do an element by element division, not a matrix division. plot temperature versus voltage, label the axis, and that's what she looks like. From this, I can read off some points. At 8 volts, so if this is the temperature sensor, I can read the voltage. If I read 8 volts, I know the temperature. If I read 6 volts, here's the temperature. So knowing voltage, I know temperature. And that's kind of the way thermometers work, electronic thermometers. In MATLAB, you can do for loops. What for loop does is it just repeats over and over again. So for example, suppose two people are playing a game. A rolls 5 10-sided dice and takes the sum. B rolls 4 12-sided dice and takes the sum. Whoever has the highest total wins. What's the chance of a win? Well, the idea here is play the game once. So for one game, I'm going to roll 5 10-sided dice. So this is 5 random numbers times 10 gives you numbers 0 through 10, round up, numbers 1 through 10. Here are 4 12-sided dice. Player A is the sum of the 10-sided dice. B is the sum of the 12-sided dice. Now if statements. If A is more than B, A won. If it's equal to B, it's a tie. Less than B, it's a loss. And notice that for equals, I need a double equals. A single equals is a sign, a double equals is compare. If I can play one game, repeat for 10 games. And so here's the score. A lost, A won, A won, A won, and so on. So we sit there and it looks like the program's working. It's keeping the correct score. That's for 10 games. Now that it works for 10 games, play 10,000 games. So I'm going to comment out the display, because I don't want to have 10,000 displays. Just display the result at the end. After 100,000 games, A has won 54% of the time, tied 4%, lost 41%. So this is the power of MATLAB. If I want to know something like what are the odds of this game, that's actually fairly hard to calculate. But with a Monte Carlo simulation, if I can play a single game, I can play 100,000 games. And if I play enough games, then the odds will be pretty close to the true odds. That's called Monte Carlo, something MATLAB is very, very good at. That's a for loop. I'm going to play a fixed number of games. There's also a, let's see, A and B are playing a match. A's got a 55% chance of winning the game, 45% chance of losing the game. The match consists of 7 games. Determine the odds that A wins the match. This is also a for loop. There's always going to be a 7-game match. If A has won 4 or more games, A has won the match. So one way to do that is first play a small number of games, like 10 games. For each match, I start out at 0-0, even score. Then for 7 games, I play and count how many times A won, count how many times B has won. So this is an if then else statement. Either A wins or B wins. At the end of the match, so here's the end statement. At the end of the match, if A has won more games than B, A has won. If it's equal, it's a tie. With 7 games, it'll never be a tie. Otherwise, it's a loss. So for the 10 games, here's the score. 3-4, B won. 4-3, A won. 3-4, B won. 1-6, B won, and so on. That looks good. Now that that works, let's play the game 100,000 times. Take out the last display, play 100,000 times, and see how many times A won. So A won 60% of the time, was never a tie. Odd number matches, games, not surprising. Lost 39%. So with this, I determined that A is going to win 60% of the time under this format. Those are for loops. A while loop is a little bit different. Instead of playing a fixed number of games, I could do an infinite number of games, such as if I have to be up by 3, then if A wins, then B wins, I'm back where I started. I have to be eventually up by 3 or down by 3. So this could go on for infinity. That's a while loop. So first off, I'm going to sit there, start out at even, and then while. As long as the difference between A and B is less than 3, keep playing. Once somebody's up by 3 games, kick out of the while loop. So here's the end of the if, Here's the end of the while. When you kick out, see who won. So here, A won 8-5, A won 3-0, A lost 0-3, A won 9-6, 4-1. Notice the difference is always 3. That's good, the program's working. Sometimes A wins, sometimes B wins. That's also good. That means it's random numbers. So once I'm convinced it works after 10 games, now try 100,000 games. Same format, change this to 100,000, and A wins 64% of the time. So that is homework. Oops, one more problem. The last one is kind of a tougher one. This is sort of like tennis. I have to win at least 4 games and be up by 2. So here, one way to do that is I'm going to start out. Just play 10 games, see if this works. Start out even. Keep playing until somebody has won 4 games. And once somebody has won 4 games, I'll then check. Is somebody up by 2 games? And that should be a 2. As long as somebody isn't up by 2, keep on playing. That's sort of like the last problem. If I am up by 2, skips over this. If I'm not up by 2, I enter this loop. And finally, when somebody's up by 2 and has won 4 games, the match is over. So in this case, playing for 10 games, the winner has always won at least 4 games. That's good. And I'm up by 3, up by 3, up by 3. It should be up by 2. And that's the mistake I made right here. So this is a little bit wrong. Once you're happy with it working for 10 games, now play 100,000 games. And you see under this format, A wins 65% of the time. So that is solution number 1 for ECE 111.